So in this video, we're going to focus on the sine and cosine law once again, except we're going to be trying to apply it to real life world problems, okay, with actual people, actual situations, okay, not just random numbers, random triangles, okay? So first question here, Jackson's golfing on a local golf course. He steps up to the 8th hole, which his rangefinder estimates is about 250 yards long. Okay, so the hole's 250 yards. The wind carries his ball 10 degrees to the right, and the ball lands on the green a total of 265 yards from where he started. How long is his next putt? So the first thing we're going to do is we're going to kind of draw this out. So if this is Jackson here, okay, he's stepped up to the hole on the golf course. Okay, so the 8th hole is 250 yards long. You see that here, the wind carries his ball 10 degrees to the right. So we know that from Jackson to the hole, okay, this is going to be 250 yards. Okay, and it says the wind carries his ball 10 degrees to the right. So we're going to keep going here, 10 degrees. Okay, and it says the ball lands on the green. So the green is just where the hole is, kind of the thin layer of grass. And the ball lands on the green a total of 265 yards from where he started. So that means that this distance here is 265. How long is his next putt? Okay. So we can complete this triangle here, and we're looking for this because if he hits it 265 yards, this is where the ball ends up. This is where the hole is. So he's putting from here to here, trying to get it into the hole. We're trying to figure out the distance x, the distance of his next putt. So notice how the angle we have here is opposite to the side we're looking for. So anytime that happens, that means we're going to be using the cosine law. Okay, so if we have our triangle here, we know that x squared is going to be equal to, I'll call this a and I'll call this b. A squared plus b squared minus 2ab cosine, and then this is going to be 10 degrees, right? Because this last angle we're taking the cosine of, that's the angle that's opposite to the side on the very left. Okay, so the x we're looking for, opposite side, the opposite angle, it's going to be 10 degrees. So x squared is what we're looking for. A is going to be 250, so a squared is 250 squared, and because I don't have a ton of room, I'm just going to kind of do that step in one, so I'm going to go 250 squared plus 265 squared. So that's 132,725. Okay, and then remember we're subtracting 2ab cosine 10. So we're going to go 2 times a, which is 250, times b, which is 265. So that's 132,500. So we're going to take that and multiply it by the cosine of 10. Okay, we're going to multiply it by the cosine of 10. That is going to be 130,000 approximately. Okay, so the actual exact amount is 130,487. Okay, so x squared is going to be the difference between those two numbers. Let me just calculate it here. So 132,725 minus what we just had. So that's going to be 2238. So 2,238. Remember, this isn't our answer. This is our answer squared. So to find our x, we just have to square root that. And it's going to be 47.3. Okay, 47.3, and this is going to be in yards. Okay. So the distance from where his ball landed to where the hole is 47 yards. That's going to be a pretty long putt. Must be a long green, but that's going to be your answer there. And remember, for all these questions, if you got something like maybe 300 yards, you'd know that was off, because if you were to draw this diagram to scale, which we roughly did, you would see that x is going to be quite a bit less than the 250 and the 265, right? Okay, so Dylan has a kite on a string with length 412 meters, which forms an angle of 68 degrees with the ground. Okay, so first let's just draw this. So if this is the ground here, okay, and this is Dylan. Okay, so he has the kite. Just for simplicity purposes, I'm going to draw the kite kind of on the ground here. And it says it's 68 degrees to the ground. So 68. And I'll just draw Dylan down here. I'll put D here for Dylan. Someone nearby notices that the angle formed by the kite, so the kite is up here, formed by the kite, and the flyer is 99 degrees. Okay, so the observer is here. Okay. And the angle that they observe right here between them and the kite and Dylan is 99 degrees. Okay, so I'll put O for observer. How far is the observer from the flyer? Okay, so we need a side length, and the side length is going to be this 412 here. So it says the length of the string from Dylan to the kite is 412 meters, right? So if we're looking for the distance between, because it says how far is the observer from the flyer, so how far is the observer from Dylan? Well, the observer is on the right, Dylan's on the left. We know this 412. We know this is 99, so that's one pair, right? 412 and 99, an angle side length pair. And say this is x, the distance between them. We would need this angle if we wanted that second pair, right? Because remember, if we're looking for things in pairs, we're going to use the sine law. So I'll call this alpha. Okay, so the sine of alpha over x equals the sine of 99, right? This angle here over 412. Okay, so notice how we have two variables here. We have alpha, the angle that we don't know, and x, the side length that we don't know. X is what we're trying to solve for, so that must mean that we have a way to figure out alpha. Well, notice how we already have two of the angles inside the triangle. And triangles all add to 180 degrees. So if we want this unknown angle alpha, we take 180 degrees and we just subtract the other two angles we already know. Okay, so alpha is going to be 180 minus 68 minus 99. Minus 99, so that's going to be 13 degrees. Okay, so 13 degrees, that's alpha. So where I see alpha, I'm just going to write 13 degrees. Okay, so just to make this equation a bit easier to solve, see how this x are variables on the bottom? We would have to do cross multiplication and kind of do an extra step if we left it the way it is. So let's just flip both sides. Right, so we can flip both sides, take the reciprocal, it's called. So x over sine 13 is going to be equal to 412 over sine 99. Okay, so we can do this because it doesn't matter what's on the top and what's on the bottom. As long as you flip it on both sides, it's going to be the same thing. Because if these two really are equal, that means that flipping two things that are equal will also be equal. So now we want to get rid of this sine 13 over here. So we just multiply by sine 13 on both sides. Okay, so on the left side we just have x. And on the right side, it's going to be 412 times sine 13. And we're going to divide that by sine 99. So that's going to be about 94. And remember, we always need our units. So this will be meters, because they gave the length of the string for the kite in meters, 94 meters. And let's just see if that makes sense. Yeah, that looks about right. We didn't draw it quite to scale, but this is about maybe between a quarter and half of this 412, right? 94 sounds about right. Cool. Okay, last question here. Two soccer players, Ryan and Brendan, they're in the midst of a semi-final game. So Brendan passes to Ryan, who's 15 meters away, and forms a 100-degree angle with the center of the net and Brendan. The angle created by the center of the net to Brendan to Ryan is 38 degrees. How far is Brendan from the center of the net? Okay, so like always, let's draw a picture. So we'll say, actually I'll draw it a little better. We'll say that this is the net right here. Right, this is the net. So we'll say this is the center of the net. I'll call it C for center. Okay, so Brendan passes to Ryan, who's 50 meters away. The angle created. Okay, so let's say Brendan's right here. So this is Brendan right here. Brendan passes to Ryan. Let's say Ryan is about here. So this is Ryan. Okay, so right here. How can we figure out that distance? Well, it says Brendan passes to Ryan, who's 15 meters away. So, actually, the scaling is going to be a bit off for this. I'll try and make it a bit better. So here it says forms a 100-degree angle with the center of the net and Brendan. So that would mean that the angle between Brendan and Ryan would have to be 100. So if this was Ryan and this was Brendan, this angle here is 100 degrees. Okay, and if this is the distance from the center of the net to Brendan, we'll just call that x, right? Because we're trying to figure out, it says right here, how far is Brendan from the center of the net? So this x is what we're looking for. We know this is 100 because they tell us in the question. And it also says Ryan is 15 meters away from Brendan. So this length right here is 15. Okay. And it says here, the angle created by the center of the net, so C, to Brendan, so from here to here, to Ryan, so from here to here, is 38 degrees. So that means this angle in between here is 38 degrees. So the angle that those three vertices subtend is 38 degrees. How far is Brendan from the center of the net? Okay. So we're looking for x, right? And we have two angles inside the triangle. So maybe we don't need the third one, but just in case, let's figure it out because it's not a super hard calculation. So let's call this, once again, we can call it alpha. So alpha is 180, right? Minus 100 minus 38. Okay, so minus 100 minus 38 degrees. So 138, that's going to be 42 degrees. Okay, so alpha is 42 degrees. And I'll just draw that in here. So this angle right here is 42 degrees. Okay, so we might need that, we might not. Let's just write it in just in case. So we're trying to find this distance x. Okay, we have the opposite side to x, or the opposite angle, which is 100 degrees. Okay, and we have this 15 here and this 42 now. So since we have one full pair and one piece of information from another pair, we can also use the sine law on this one. So x is a side length, and we always want the variables to be on the top, just to make it a bit easier. So let's do x on the top for our variable over the sine of its opposite angle. So over sine of 100. That's going to be equal to our other side length, which is 15, right, over the sine of 42. Okay, so multiplying by sine 100 on both sides, x is going to be 15 sine 100 over sine 42. Okay, so 15 sine 100, that's 14.8, divided by sine 42, that's 22.1. 22.1. So let's just look at this here. This 22.1, we're saying that that goes right there. That looks about right? Because 15 is about 2/3 of that, right? So it kind of makes sense if we think about scaling and everything. So yeah, that's how you'd use the sine or cosine law to figure out these distances in these cases, or these angles. So the first one here, we use the cosine law. The last two, we use sine law. We can use like different laws depending on the information that we know. If we know two angles, we can figure out this third angle here. But even if we didn't, we could also sometimes use another law to figure it out before we even find that piece of information. So it really depends on what you're given, but always just draw it out, think about it rationally, and once you have your answer, always compare it to your diagram. That can make a big difference in determining if it looks right or wrong, okay? So I hope this video is kind of informative into how we could use the sine and cosine law. It's not just random numbers, like I said. It's always nice to see when you can apply your math to actual problems. So I'll see you in my future lessons here, and have a good day.